start having that little square in the middle of that red circle says we're recording. So here we are. I picked out these problems because the probability people got them, the percentage of people who got them correct um, was low. And so the first one this happened on was problem 3, which is good because I think John asked about this. And part of the problem here was that this 2 of these statements are true out of 4. This kind of problem in Sakai tests uses right minus wrong grading, and there was instructions on how this works at the beginning of the exam, but I think, at the moment where you start the exam, you're kind of fired up to get to the questions, and I think mostly people skip the instructions. Uh, so so here we go. So in any case, there's 2, this is one of these, there's a PDF, but I don't tell you anything about the PDF really. But essentially there's 2 good facts here. One is that that's not a good enough color. One is that the random variable is continuous, and the other is that the random variable is non-negative. And and so non-negative really is a fancy way of saying that the probability that x is less than 0 equals 0. Like the random variable x is either going to be 0 or some positive number, right? So when you look to see which answers are true, right? Uh, the fact that the random variable is continuous really tells you, like from the first day we lectured about continuous random variables, that the probability x equals 3 is equal to 0. And that's because a continuous random variable has the property that the probability of any particular value is indeed 0, right? It's always continuous over some interval. It's always intervals that have non-zero probability. So the second statement is the other true statement, because the probability that x equals, the probability that x is less than or equal to 0, right, is going to, actually, let's do it this way. I have to do a little erasing here. If I was doing this as a recording, I would back up and just have a do-over. That's why my recordings are so fabulously perfect. You can't tell, maybe I'm smiling, but indeed I am. Okay, so so the probability x is less than 0 for continuous random variable is the integral from minus infinity to 0 of the PDF, right? And this is going to be 0, and because the PDF is non-negative, it says that the PDF is 0 for x less than 0. And so the other true statement is B. The PDF at -3 has to be 0 because there is no probability for negative x. And then finally, the other 2 statements are wrong. Like C and D are wrong. The PDF at 3 could be anything. I haven't told you enough information. And similarly, the PDF at various values of x could be bigger than 1 or less than 1 or whatever. Those 2 statements could be true for some PDFs, but in general are not true. Okay, so let's go on to the next question. So Whale asked, if you gave the question half correct, why do we not get half the credit? And this is this complication with asking a question like this. If you get 1 right and 1 wrong, the question is, how do you penalize the wrong answer? So in Whale's system, it's like you should get credit for the one you got right, but no penalty for the one you got wrong. But if you do that, then you should check all 4 boxes and you'll get the 2 right, and there's no penalty for the 2 wrong, and you get full credit. So that's no good. And somehow this format requires you to have a penalty for checking something as true when it's not true. Uh, so we're kind of stuck with this. I think in the future, I think there's a way in Sakai to make these be equivalent to true false statements. So you put up the block of, there's some facts, like it has a PDF, it's non-negative, and then you have a true false for each one. Uh, and then you can have independent grading. So that's probably what we'll do in the future, because I agree that this format where, oh, you know something but you get 0 because you mistake something else seems kind of mean. But I didn't quite understand that so much before I made the exam. I had to turn on my thing. So this version of the problem, like it was one of the like 8 versions. 65% of the class got it correct, and I have no idea why this version was so much easier. If anybody has any obvious reason why, I'm speak up or type something into chat. Anyway, it's kind of the same question. It's continuous, non-negative, and A is true because each value of X has 0 probability. D is true for the same reasons as on the previous slide. B and C are not true. I mean, B is really ridiculously not true because a PDF can never be strictly negative. I mean, that's a really easy. Maybe it's because that one was so easy to exclude, it made people get the right answer more often than not. Okay, so that was problem 3. I forgot to turn on my thank you, Christina. Yeah. Okay, so this version, 25% of the class got it correct. And A is true for the same reasons as on the other one. B seems like it should be, it's one of those statements that's true, but looks like it's false. It's true because of, ah, okay, so we have to be a little more careful on this one. So this one version of the problem, it's continuous, but it doesn't say it's non-negative. So some of you have this version. And so we know that f of -3, like its PDF, has to always be non-negative. So we don't actually know. Now this is why I waste a lot of time in class. This is not true necessarily. But the statement B is true. PDFs are always non-negative. And we don't know about C or D if they're true or not, because we don't know anything else about the random variable X. Okay, so apparently this was tricky because I didn't read it carefully, and okay, so let's we have some comments here. Tim says, "Isn't D also true?" And the answer is no, because we don't know if it's non-negative. Like this is the version that it deletes the words non-negative, so the probably X less than 0 could be bigger than 0. And Maharul says, what does it mean to say fx of x equals f of x? So what it means is that with the subscript capital X, it's specifically the PDF of random variable X. And then we're saying it's equal to some function of X, just some generic F, right? Where I'm not telling you exactly what it is. like I could have called it g of x, but I thought that would be more confusing. And mostly we wrote this equals this so that in the answer key you can just write like f of -3 and f of 3 rather than a subscript because Sakai makes it hard to type in those subscripts. So so that's why it was in there. Okay, so we'll start. We had these Poisson questions about Wawa, and this one was supposed to be kind of a gift because it's really a discrete random variable PMF question, right? The number of sandwiches in an interval is a Poisson random variable. And this version, people did medium crummy, 33% got the answers right using some people got a version that had the first answer key A through E, and some people got exactly the same problem with the second answer key. Uh, uh, you know, A through E. And in this version of the answer key, the bold-faced A is always the right answer. But when you load it in Sakai, you tell it, oh, this one's the right answer, but it gives you them in a random order. So, uh, uh, so the catch here, of course, um, is that the probability of at least one is the probability n tau is greater than or equal to 1, which is 1 minus the probability n tau equals 0. And this is 1 minus p n tau of 0. And tau is equal to 2, right? So this is 1 minus 2 times 2 to the 0 e to the minus 4 over 0 factorial 1 minus e to the minus 4. And this is one of these problems where people did, for some reason, slightly better on the second version where where the correct answer is all the other answers are wrong. And I think that's because if you did the calculation and you kind of got confused about something, the logic or whatever, then you would come up maybe with none of the answers B through E, and then you would be like, well, okay, I got the right answer. It's A. It's all the others are wrong. Okay, so I don't see any comments here, so let's. So in this version of the problem, uh, it happens like kind of, you know, there are like 8 versions, and some people kind of got a gift, right? In the sense that, like, you know, 92% of the people who got the answer key of the first row got it right, and 76% got it right with the answer key in the second row. Uh, but essentially, this is a simpler logic, right? Like exactly 2 sandwiches is just the probability n tau equals 2. So it's probably n tau of 2. And just I think the logic is a little easier there. Uh, yeah, okay. So I have a private communication that was like, my answer key says the answer is wrong. The answer is, yeah, right. If you have a different version, your answers will be different. So there were a lot of versions of this problem. All right, so actually the reason I included this problem, right, was it was kind of the predecessor to the next problem where I ask you about how long do you wait until you see a sandwich sold, and that one the success rate was very high. So I guess everybody either saw the lecture I did about that or saw that I worked this out on the old midterm, and people were ready for that. So I'm going to skip that and go on to the to the next tricky problem. So this problem was, the success rate was pretty low, 29%, and I think it's really mostly a question of um, like this right versus wrong, right minus wrong grading, messing people up. So so for instance, like for part A, the probability x is less than or equal to 1 is the CDF at 1. And then if you study the three cases carefully, it's the middle case. So it's 1/3. So A is correct. The probability x is less than 2 is the CDF at x, but at 2 minus, because if you plot this CDF, right, what we have is this jump at 2, where we jump from like 2/3 up to 1, right? So this is testing whether you knew that that when you have this jump, that the strict inequality here, x strictly less than 2, that it's this limit from the left, right? The limit where you're just a little bit below 2, right? And so this is equal to 2/3, right? So this statement is not true. X is strictly, right? And then the probability x is greater than or equal to 2 is in some way what we're looking for is here, that is for you to realize from this graph that x can't be bigger than 2, but in fact x can be equal to 2. So the probability x is greater than or equal to 2 is the probability x equals 2, and that's 1/3. It's the height of this jump from 2/3 to 1/3. The height is 1/3. It's exactly the probability x equals 2. So this is wrong. And then finally, this one is correct, right? The height of the jump is 1/3. And I can't really tell from Sakai uh, uh, which one of these answers was the one that fooled a lot of people. It's quite difficult to tell. Oh, right. I'm trying to turn this. So this version, I just started the recording, so I have to start over. So this version is almost the same as the previous version, but kind of uh, the place where the discontinuity is now 3 instead of 2, and the height of the jump is 1/4 instead of 1/3. Right. So the first statement is kind of the easy one, right? The probability x is less than or equal to 1 is the CDF at 1, which is 1/4. So that's good. The probability x equals 2. So this is testing that that at x equals 2, there's no jump discontinuity, right? So in fact, this probability is 0. So this is not true. The third statement, in fact, the probability x is greater than 3 is 0, right? So it's exactly the opposite of what you would have thought. And the fourth statement is the correct one, because that 1/4 is exactly the height of this jump at 3. So frankly, I was hoping to kind of have given you guys a gift that this would be an easy one. So I don't really know what went wrong here. If anybody wants to volunteer, like, oh, I had this, and the one that seemed to be true was something, jump in on the chat and speak up if you want to reveal your your So we have a question here from Tim, and he says, what does that mean? Probably x equals 2 equals 0. If you plug in 2 to the CDF, the answer would be a half. And what this means is the following. When you plug in 2 to the CDF, you indeed get a half, but this is the probability x is less than or equal to 2. So in this case, x is a mixed random variable, and it takes some values between 0 and 3, and the probability x is less than or equal to 2 is all x's between 0 and 2 have probability a half. But in fact, right, because it's mixed and it acts like a continuous variable for x is less than 3, right? The probability of exactly equal to 2 is 0. And this is like something I think we'll put on the final exam and make sure everybody knows it, right? Is that is again here at x equals 2, right? There is no jump in the CDF, and if there is no jump in the CDF that it has continuity there, then the probability of that particular value of x happens to be 0. Okay, so we'll pause. This was something you see in Sakai that because we did the exam this way, um, you know, so this is two different versions of this question 11 out of like I think 8. And in this version, these two versions, they both had the same text. Uh, the text said random variable x is 0 mean Gaussian. Probably x is less than or equal to 3 is 0.7734. What is the variance? And the two problems were almost the same. I mean, they in fact, I'm looking at this, and the only difference is that the answer keys are slightly different. The correct answer will be 16, and I just made up some other random numbers for possible answers. So we we're recording now, and Guillermo says that the variance is sigma squared, and the second answer key has sigma as one of the answers, and he thinks that's what led people astray, and probably he's right. Um, in any case, if a lot of people did it wrong, so let's just work through it. The first thing to note is that x is 0 mean, so mu x equals 0. And then the second thing is that, oh, the probability x is less than or equal to 3. And this is maybe what makes the problem a little bit difficult, is that I didn't tell you that, that you have to kind of give a name to sigma x. So that's probably x minus its mean over sigma x is less than or equal to 3 minus the mean over sigma x. Right? And but mu x is 0 and sigma x is unknown. So this is equal to phi of 3 over sigma x. And then I tell you this is 0.7734. And then this is kind of nice because this was an open book, open notes exam. You're supposed to have had a phi table handy. I think I told you a day or two before, make sure you do. And so you can look up on a table 0.7734 implies that 3 over sigma x is 3/4, right? So that's 3/4. And so sigma x is equal to 12 over 9. Is that right? No, 12 over 3. Okay, I'm an idiot, maybe. Trying to figure out how to use my eraser. No, erase. Oh, I don't know why. This program has an annoying eraser, which I don't really understand its function. So that's 12 over 3 equals 4. So the variance is sigma x squared. That's why people went wrong. 16. Okay. So the reason the second version fouled people up is that you got to sigma x equals 4 and you're like, okay, I see my answer 4. But in fact, that's a bad answer. So this says when I make up more of these problems in the future, I should always include, if I ask for the standard deviation, always include the variance as a misleading answer. And if I ask for the variance, always include the standard deviation as the misleading answer, uh, just to make things more fair. So some of you got the easier version that didn't have a misleading answer, and some of you didn't. Um, that's just kind of random chance. People who are not watching this will should sort of, go. If you're watching this in a video, you should thank Christina for fixing me. Okay, so these two versions had two different success rates, and but it's the same problem, just a different answer key. And so in any case, going to the problem, x and y are identical and they're bivariate Gaussian and there's zero mean and unit variance. So we have the first fact that mu x mu y is equal to 0. We have the second fact that sigma x sigma y, they're both 1. And then we have this correlation coefficient. And the way we have to use the correlation coefficient is that we have to first know how to use that to find the variance of x plus y. And everyone should remember this formula that, oh, it's the variance of x plus the variance of y plus 2 times the covariance. And then you have to remember that the rho is equal to the covariance of x and y over the square root of sigma x sigma y. But in fact, I think in every problem on this exam, the I made sigma x and sigma y equal to 1, so the covariance was exactly equal to rho. And so in fact, this is equal to minus 1/4. And so this is just the covariance. So we have the variance of x plus y is equal to 1 plus 1 plus 2 times minus 1/4. So that's 3/2, right? And so now we're kind of all done here. Like if I say w is x plus y, then the question we're asked is the probability w is strictly greater than 1, right? Which is the probability w minus its mean, which is 0, divided by its standard deviation, is greater than 1 over its standard deviation. Right? And so this is sigma w, 3/2. And so this is exactly q of 1 over sigma w, which is q of 1 over the square root of 3/2. So it's q of the square root of 2/3. And so A indeed is the right answer. And I think my thought here was that people who did the second version of this problem, there are a bunch of places you could screw up in this calculation. And if you mess up without, and then you're like, oh, I see, I have all the other options are wrong. I'll guess that, and then that is the right answer, which you may or may not have done the work correctly, but you got it right by not arriving at one of the other wrong answers. So So I think the lesson here is that when there's a bunch of calculations in a couple different places people could go wrong, then all the other answers are wrong is not a good correct answer because it's too easy to just arrive at it. Okay, so now we have some comments. Uh, oh, okay. So let me go back and address the comments. So first I'll do John's question. He says, why is standard deviation square root of 3/2? And I can see there's actually a small typo on my slide. Like I wrote this, but I have a typo because I'm working live. This is sigma, this is variance. Uh, it's variance of x plus y is 3/2. And then I called this x plus y, called it w. So this is sigma w squared. But when you do normalization, it's with standard deviation. So if sigma w squared is 3/2, then sigma w is the square root of that, is root 3/2. So that answers John's question. I hope so. And then Whale says, oh, there was another question with rho equal to minus a half. And that version is almost the same. So I'll take a chance here. So with rho, I'll write in red for the rho equals minus a half, right? Then you get variance of x plus y is 1 plus 1 uh, uh, plus 2 times minus a half, right? So this is actually the easiest version of the problem because you get variance of x plus y equals 1. And so probability of x plus y less than 2, right, is equal to, well, it's in fact exactly equal to phi of 2 over the standard deviation, which is 1. So it's phi of 2. So I've skipped some steps there, but you can fill them in because the means are 0. But the key is that the variance is 1. Okay, so I think I've answered those questions. So I'll stop the recording. All right, got my recording going. I didn't have to wait for Christina to send me my reminder. Okay, so these are the problems where like, oh, these are new. Uh, um, I've been kind of working out the solutions to problems of this type, kind of my hobby for the last couple weeks for a variety of reasons. I keep thinking that there's an interesting research question hiding in here that I don't understand yet. But so let's do the first version. So so this problem is really like uh, you know, it's really testing, do you know how to do these problems? So here's x and y, and um, like if you look at, we're testing x and y are independent, identical, continuous, uniform, 0, 1 random variables. So there's a lot of facts in there. And the main fact is that, I hate it when I use this wrong marker. The main fact is that they both have this same PDF, right, which is equal to 1 and 0 otherwise. And because of independence, like, wait a minute, I gotta get rid of that blotchy thing. Right, the joint PDF is the product of the individual PDFs, right? And so So this PDF is just one on the box. So here's a box with corners at 1. This corner up here is 1, 1. And in that box, uh, the PDF equals 1. Okay, and so now the next part of the problem uh, is you write this down, and you're like, what does this look like on the XY plane? And the key thing is to realize that because X and Y are both non-negative, this denominator here is always non-negative. So I'm learning that I should, when I'm doing this as a recording over WebEx, I should move this pen slowly to do this, right? And so this is equal to the probability X is less than or equal to 1/4 X plus Y. So now that I've done this step, I'm actually going to solve this problem a different way. I'm going to generalize the solution. And this is kind of why I'm obsessed with this problem. Like, let's make this quantity be W, right? So if you ask this for a general W, then what you're really doing is, oh, you have a random variable here, capital W, which is this ratio, and you're really deriving the CDF of the ratio. And so it turns out the problem is almost as simple with the general W, right? So let's do that. Hey, could you guys hear that? I think you could call from potential spam. I don't know who is now. Maybe Verizon is doing this. Okay, so maybe I'll edit that out of the recording, or maybe not. Okay, so let's just change this to be everything I said before is still true. I can put this in as a W here, right? And the thing to know is that X and Y are both between 0 and 1, and X is always less than or equal to X plus Y because both are positive. So this W is always going to be between 0 and 1. So we really only have to solve this for values of this little w between 0 and 1. And so now we can keep moving here and say, oh, this is the probability 1 minus w times uh, x is less than or equal to wy. And so this is the probability that y is greater than or equal to 1 minus w over w x. So this is actually pretty simple. Like if the w was 1/4, this would be 3/4 over 1/4, and it'd be y is greater than or equal to 3x, right? So so this is some number where in the example of 1/4, it'd be y greater than or equal to 3x, right? So now what you do is you draw the straight line where y equals 1 minus w over wx, right? And the probability we're interested in is this probability. The probability we're in that triangle, right? Because you have to be above the line where the two where this is equality, right? But you also, to have the event be true, you have to be in the box, right? And so um, so the catch here is that At this corner point here, try to choose at this corner point right there, right? That corner point corresponds to y equals 1. And so x equals w over 1 minus w times 1, right? And so for instance, when w is a quarter, um, x is equal to 1/3, right? So this, the width here is w over 1 minus w, right? And the height is 1, and and the probability that you're in that box, like you can set it up as a calculus problem and do the integrations, but really it's just the joint density, which is 1 times the area. So it's just in fact equal to the area, right? So it's the probability of the area of that of that triangle. And so that triangle is 1/2 times the base, w over 1 minus w, times the height, which is 1. So it's w over 2, 1 minus w. And then the case we were considering was w equals um, duh, 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 w equals 1/4. So with w equals 1/4, it was 1/4 over 2 times 3/4, and the answer is 1/6. So in fact, this is correct. And I guess this is another case where something tricky means you could make mistakes and not get any of the other answers. And then for the second answer group, all the other answers are wrong is correct. And but in fact, in this problem, it made no difference because uh, in this problem, it made no difference. Maybe because people were running out of time and the complication was tricky. But but that's how this problem works. So I'll comment here that this solution works. It's okay for w less than or equal to 1/2. Like when w is bigger than 1/2, you end up being on the other side of that rectangle. And for people who had a version where the w was bigger than 1/2, in fact, I reversed this inequality so that you had an equivalent problem where your triangle looked like this. So in fact, it was equally easy, but just everything was reversed. So then I asked this version of the problem, and got some funny answers with there were, I think 8 versions of this, and one of them, a pair of them, was this same problem statement: x and y independent, identical, exponential, lambda equals 1 random variables, and the problem was the probability this ratio is less than or equal to 1/4. And the weird thing is, if I, this version, the first version, all the other answers are wrong. People got the correct answer. 29% of the people who got this problem got the correct answer. But if I change the 1/4 to 1/3, and I change the one of the wrong answers, D, to 2/3, somehow 48% of the people got the right answer. And this is kind of mind-boggling to me. Uh, so I don't know what's going on. Um, but if you solve this problem, this one is maybe the hardest problem in the exam. We'll solve it, and we'll solve the probability x over x plus y is less than or equal to some w. And once again, we only have to solve this for w's between 0 and 1 because the random variable x over x plus y is always, because both random variables are non-negative, it's always between 0 and 1. So when we go to solve it, this one you really have to use a little calculus, right? So you have x, you have y. If you combine the fact that they're IID exponential lambda equals 1, right? You know that the joint PDF is the product of the individual marginal PDFs, and that you know that lambda is 1 for both of them. So it'd be e to the minus x, e to the minus y for x and y greater than or equal to 0, 0 otherwise. So what was the box in the previous version of the problem becomes x and y can be any point in this, in this upper right quadrant in the non-negative orthant. Maybe it's a quadrant, not an orthant. Okay, and so now when we set up the problem, we have to say, okay, what's the probability x? I have x over x plus y is less than or equal to w. And this is the probability x is less than or equal to w times x plus y. This is the probability 1 minus wx is less than or equal to wy. And this is the probability that y is greater than or equal to 1 minus w over w times x. And so now you draw this line on the plane. Could be, so the slope of this thing, of this line is 1 minus w over w. And it in fact could be any slope, right? It could be very close to 0. Like if w is very close to 1, the numerator is close to 0, the denominator is close to 1, and this thing will be close to 0. But as w goes to 0, the numerator goes to 1 and the denominator goes to 0. This could be arbitrarily, it can blow up to infinity as w goes to 0. So this slope could be anything. But we'll solve it in general. And then, so this line here is y equals 1 minus w over w times x. And we're interested in the probability of being up in this region. And so this is equal to, and now we have to do some fairly strenuous calculus. So it's the integral from x from 0 to infinity, and then the integral of y. So we're going to do the y integrals exactly the way these blue stripes are shown. The y's go from 1 minus w over wx to infinity, and that corresponds to starting here and going up to infinity. All right, and then I plug in the joint PDF, e to the minus x, e to the minus y. And then the dy comes first, and then the dx comes second because the x is the outer integral. So this is 0 to infinity e to the minus x. And then the inner integral is minus e to the minus y 1 minus w over wx to infinity. And then here's my outer dx. And e to the minus x. And then the inner integral, this is 0 minus e to the minus y evaluated at this lower limit. And so this is e to the minus 1 minus w over wx dx. And then I look at this thing and I have to combine the two exponents. So it's e to the minus, and it's 1 plus 1 minus w over w times x dx. And you might be like, oh, this is a real hairball. But in my case, I knew what the answer was going to be. So, uh, so we do the next step. So this is 0 to infinity, and you get a w plus 1 minus w. The thing simplifies e to the minus x over w dx. And so this integral becomes minus w e to the minus x over w is the integration of that, because w is just a constant here, right? Then we evaluate at 0 and infinity. So I get minus w uh, times, the w is just a constant, times 0. Okay, wait a minute. uh, Times 0 minus 1. So the answer is W. Okay, so the answer is W, and in this problem, uh, uh, W is 1/4, and there is no 1/4 in the answer key. I'm trying to find my this thing. So there is no 1/4 in the answer key, and so the correct answer is, in fact, all the other answers are wrong. And I guess probably people ran out of time before they could do the calculus and do it wrong, and then conclude all the other answers are wrong is the right answer. Okay, so what's interesting about this problem is that we've done something a little bit interesting here, right? Which is at least interesting to me. And that's that we define this random variable w over x plus y. It's the ratio of one exponential to itself plus another that's identical, right? And what we found is that the probability w is less than or equal to w is equal to w for w's between 0 and 1. As we learned is that w is continuous uniform 0, 1. So when the x and y are both exponential and identical, you get this result. And it turns out it doesn't matter that lambda equals 1. In fact, you get this result for any choice of lambda if you work through the calculations. And I actually knew this result. But then I guess that what I thought was interesting, right, was that the other example for the continuous uniform x and y, you get a completely different, more complicated result that has much smaller variance. And I honestly don't understand why exactly that is. I feel there's an intuition there that should be understood, but I don't. So, so it's interesting to me, and maybe you're like, oh man, he's really boring me to death with this. Oh, okay. So this problem, uh, I really like this problem. I worked very hard to set it up because I had to make these little plots. But the key thing is to kind of like uh, look at each of these random variables. You'd be like, oh, the center of this distribution is like right here and right there. So like you can look at this first plot and be like mu x is equal to -2. And mu y is right in the middle there is -1, right? And you can also be like, oh, there's like a a pretty narrow ellipse, like maybe it's zero point 0.8 or zero point 0.9. It's got to be at least zero point 0.7. So when you look through the options, you're like, oh, mu x is -2, mu y is -1, rho equals zero point 0.8 is like around the right answer. It's got to be this one. And if you look at this one, you're like, oh, here we go. The center is that x is -2 and y is 1, right? And you're like, this is the only one where mu x is -2 and mu y is -1. So it has to be that one. And you know, maybe the next one is you're like, oh, the center is at -1, -1. And the other thing is the slope, like it goes the wrong way. It's negative correlation. And here we are. So, so the other three, like you do the same thing. So for instance, rho is 0.95. This is the super narrow one, right? And 0 and 0. And so here is D. And you guys can draw the same thing and be like, this is E and this is F. And this is the problem where each one that you guessed correctly, you got, I think, 2 points for. Maybe it should have been three. But uh, I like the idea that you should be able to look at these and know kind of what kinds of correlation and mean values you're looking at. And then we'll disconnect. So uh, so I've deleted some stuff here that I see. Uh, there's two parts of this problem. One is that the x and y are zero mean and they're unit variance. So you have another one of these. The variance of x plus y is equal to variance x plus variance y plus 2 times covariance of x and y. And that number is equal to 3, right? But this is equal to 1, and this is 1. So the covariance of x and y has to be equal to 3 minus 2 over 2. It's a half. All right, so that's good. And then because they're both are unit mean, unit variance, the covariance has to be equal to rho, right? And so rho is a half. And now, maybe we don't need to know that rho is a half. Now, what the problem asks you for is the mean squared error, right? And the mean squared error, this is actually given in the problem statement, is A is x minus x hat y. So that x minus x hat is the error, and then we square it to get the squared error, and then we take the expectation to get the mean squared error, right? So we have this thing, and then we have to do some maneuvering here. This is x minus x hat is a y, because what's happening here is you observe the y and you have to estimate the x, and your estimate is AY for some careful choice of A, right? And now you do some calculations. This is, you square what's inside here. And then you take the expected value of each piece. So there's a lot of stuff being tested here. And then you have to realize, oh, this is equal to 1, right? Because it equals E of x squared is equal to variance of x, right? Because the expected value is 0. And the same thing happens to E of y squared. It's equal to 1. And you have to know that E of xy is equal to the covariance of x and y, because mu x and mu y are both equal to 0. And you found that that's equal to rho, which happens to be a half, right? And so now you're ready to plug some numbers in. So this is 1 minus 2a times a half, right? Plus a squared times 1. So this is equal to minus a plus a squared. And so now you have to choose the value of a that minimizes this function. So if you just say, oh, I have f of a, no, let's not call it f. F sounds like a PDF. I have the wrong pen here now. We'll erase that. Now I'll get the right pen. If I just define some function g of a equal to minus a plus a squared, right? Then, and if I plot g of a as a function of a, um, uh, I have a typo here. So this is equal to 1 minus, we're almost done here. This is equal to 1 minus a plus a squared. So this starts at 1, and then it goes down, and then it goes back up because it's a nice quadratic function. And the minimum is actually at a half. And if you weren't sure why, you'd be like, oh, I'll take a derivative, and I'll get minus 1 plus 2a, and I'll set that equal to 0, and I get a equals a half. And a half happens to be exactly the equal to the covariance. And if you generalize this and solve this with a general row, the general answer will always be a equals a half. And this really connects back to these cloud pictures you have before. And in these cloud pictures on the previous slide, um, when x's and y's are correlated, the straight line where y equals to rho x, right, is the best estimate of x. I'm sorry, x is equal to rho y, where x hat is equal to rho y. Rho y is equal to the best estimate of x. Essentially, x hat equals rho y is this straight line that is the least squares fit through the cloud that gives you the best estimate of x given y. So